Good morning! It's 5:30 in the morning on a Saturday. I'm here with my coffee. I'm here with you. I bet it's not 5:30 where you are. Probably about noon, 1-ish. Probably just woke up, had a little breakfast lunch. That's all right. We're ready to roll. We're ready to rock and roll. Let me talk to you about what's going on today. This is day 1 of Unit 7. Unit 7 in Algebra 2 Trig here in New York State is going to start talking about trigonometry. Finally, some stuff that's really cool. What we're going to be talking about today in class, or on this video, we're going to talk about angle measurements. We're going to talk to you about positive, negative, angles bigger than 360. We'll talk about standard position of angles. Nothing seems to be working today. Let's see if this will work. All right. Oh, there we go. All right. I don't know what's going on, man. I told you it's 5:30. My computer doesn't even want to work. It hasn't even woken up yet. Crazy. We'll talk about standard position. We will talk about quadrantal angles. We will talk about coterminal angles. We will do a little bit of practice. I'll have a link at the bottom where you can download the notes as well, somewhere. I'm not sure where. We will talk about how to convert from decimals to degrees, minutes, and seconds, and back. Talk about this mysterious thing called radians and how to use them, where they come from and how to use them. We'll talk about how to convert them from degrees to radians and from radians to degrees. And finally, at the end of this video, we'll talk about arc length. That's just the distance on the circle. It's not that complicated. Okay, here we go. You ready to rock and roll? Let me grab my pen. Let me take a little bit of breakfast juice, otherwise known as make me really excited and have fun in math. I don't know, that didn't sound right, but we'll get started in a second. Hold on. Mathematics. Let's see if my pen's going to work now. Didn't work a few minutes ago. I had to change pens. Okay, let's see. Okay, looks like we're working. First thing we're going to talk about here is positive angles. We're sure where that's coming back up. Positive angles. Okay, so for drawing. Okay, so let's talk about terminology first. A angle has a vertex, and its initial side. Wow, is that like an incredibly straight line or what? It's very difficult to draw with a fat pen like this on this big black thing. But anyway, I'm trying. This is my initial side. You know what I'm going to do? I'm going to switch to a smaller pen. Maybe that'll help out. This is my initial side. Okay, initial side. And then we have the other ray, which makes up my terminal side. Thus, terminal side. Thus, making an angle. However, I don't know if this is a positive angle or a negative angle until I put my angle arc in that goes between the two rays. That signifies, okay, I'm talking about this angle. Not the one on the outside, but the one on the inside between these two rays. And generally what we'll use is this Greek letter called theta. That is spelled T-H-E-T-A. Theta. It's the variable used to represent angle measures. One thing you want to really remember about positive angles is they go in a counterclockwise direction. That's a long word. I wonder if it is one word. I have no idea. I think it's 2 words, counterclockwise. But you know what? For this math teacher, we're putting it all in one word. What the heck? Counterclockwise directions. If you took geometry, which most of you should have last year, the counterclockwise direction is when you were talking about rotations. Your teacher told you when you're going to rotate it positive 90 degrees, you'll turn your paper counterclockwise. So you're taking it, that would be clockwise. Taking a paper and turning it counterclockwise in order for it to be a positive angle. All right, let's talk about negative angles. Same thing. We have a vertex. We have a ray. That is our initial side. We have a terminal side. I'm just going to put TS for terminal side. Get a little lazy here in the morning. And, of course, you got to put your arc in. Otherwise, I don't know if it's a positive angle or a negative angle. We'll put our theta in there. Negative angles, obvious then, must go in a clockwise direction. I wonder what we're going to do when we don't have analog clocks anymore. And for those of you sitting there going, what's an analog clock? It's that clock you can't read. You know, the one that looks like this with the handles, the big hands here and the little hands here. And you say, oh, yeah, that's 3 o'clock. Some of you are like, huh? That's really 3 o'clock? Okay. Oh, and then you learn that this is the way the clock goes for clockwise. And then you're saying, okay, then this is the way it goes for counterclockwise. And then all of a sudden, somebody comes through and just gets rid of the clock. What are we going to do for clockwise and counterclockwise? You're going to say today we're going this way, and we're going that way. That's all we're going to be able to do. All right. In my young days as a snowboarder, I constantly was in that half pipe. Never. And I was doing big, huge air tricks of things bigger than 360. I should have put a degree mark there. Degrees. So that's my initial side, and let's say that would be my terminal side. Well, you're saying to yourself, that's not bigger than 360 degrees, Mr. Krause. I got to turn this video off. This math teacher's an idiot. He doesn't know what he's talking about. Okay, hold on. More coffee. Not excited enough. This is some cool stuff. I apologize. Totally unprofessional, but it is caffeine. And caffeine is a lot of... Never mind. Can't talk about that. Okay. Yeah, you're right. If this was the angle, that might be somewhere around 110 degrees. But that's not the angle. I'm going to go around one more time. And put my theta right there. And now it's because that made that circle all the way around, that was 360 degrees. Plus the 110 degrees. So in this case, probably somewhere around 470. Wait a second. I could do it again if I wanted to. And go around again. So that'll be around once, which would be 360. Around twice, which would be 720. And then all the way up to here would be 110. If you're a snowboarder, you don't want to do that extra 110. You end up sideways and crashing and looking like a fool. All right, standard position. Let's talk about what standard position means. In the coordinate plane, so in the coordinate, by the way, if I misspell anything and you email me about it, I will ignore it. I don't harass you about your spelling. I only harass you if you talk weird. Like I seen that and I X'd them and what's the stupid thing kids are saying nowadays? I want to be trying that. Just do it. Don't tell me what you're going to do. Just do it. Oh my gosh, you guys are annoying. It's a coordinate system. That's the X, Y axes. The coordinate plane. I forgot the coordinate plane. In the coordinate plane. That's just where the X and Y axes meet on a nice flat surface. The vertex, where it is, my pen point. That's not where it is. The vertex. That's one word again. Is at... I'm having a hard time with spacing today. The origin. I don't know if I've written notes with this pen before. It's kind of annoying, actually. The vertex is at the origin, and the initial side. What did I write here? Look, is on the positive x-axis. When you are working in trigonometry and you're drawing an angle, you will never draw it off the y-axis. It will always be off the y-axis. Get that stuck in your... It will always be off the x-axis. Get that stuck in your brain, please, now. It is a big problem later on if you just can't figure that one out. All right, so what did I talk about? We talked about the vertex being at the origin. Let me draw a little bit fatter pen. And our initial side will be along the x-axis. Oh, that's so difficult to do. the terminal side, then that's really all the rules are. It's got to start here. This has to be the initial side. And then my terminal side can be pretty much anywhere I want. Let's say I put it there, and I draw in that angle measure. Okay, somewhere maybe around 135 degrees. Could be. I don't know. Maybe it's 138. Have no idea. Maybe it's 138.97, or maybe it's 135 degrees, 12 minutes, and 14.8 seconds. Huh? What's that mean? Talk about that later. But anyway, that's my angle theta. I can do the same thing with a negative angle. Initial side. That's so difficult to draw there. And let's put my angle there. And you're thinking to yourself, well, that's not a negative angle, you moron. Please, guys, be nice. Be nice. I'm a nice guy. Why can't you be nice to me? Okay. Why is that not that? Why is that a negative angle? Well, you don't know until I put this in. And I say, oh, there's my theta. And maybe theta in this case is equal to negative 299 degrees. I don't know. Somewhere around there. Who knows? Remember, to here would be 90. To here would be 180. To here would be 270. And then we went a little bit past that. So around 290, 299, somewhere around there. Who knows? I don't know. Quadrantal angles. Now here's something that doesn't come up very often. Haven't really seen it on a Radians exam, but I think it's just something you as a Trig Algebra 2 student should know. A quadrantal angle is an angle, I never write out the word angle, kind of lazy, whose terminal, oh, look at that spacing. It's like I'm a genius. Oh, this lettering is just amazing. Terminal side falls or lies on the X or Y, like those eyes, axis. Sounds like I'm all excited about how I'm doing. Oh my God, this is great stuff. Okay, so we'll still write it in initial position. Initial position means we have a vertex at the origin, and we draw our angle along the positive side. All that means then is that the terminal side ends on one of the axes. In this case, this angle would be 90 degrees. Wow, that's some neat stuff right there, kid. Let me go. Maybe try a different color for the next one. What if I put my terminal side here? Oh, okay. This is painful. So now I draw my angle, and that's 180 degrees. Or we draw, how about purple? You know, we don't have purple. This is just annoying. Are there any other colors? That's bad. I'll have to go green. Kind of boring. I hate green. Green's kind of a... Except green grass. Love green grass because that means the snow is gone. Right now it's snowing like crazy. Like, by the way, it's like negative something outside right now. Now I'll go all the way around. So we went 90, we went 180, we went 270. Here's another cue, kids. Learn the quadrantal angle measurements. That's one thing that's going to be humongous. Or as my son used to say, huge-mongous. And finally, let me see if there's another color, and I don't think there is. Oh, we'll go black. All right, so, and then we go all the way back to here. That would be 360 degrees, obviously. And there actually is one more quadrantal angle, and let me draw it in here for you. I'll take red back. If I have my initial side here and my terminal side here, then that's really 0 degrees. And that's it. Oh, wait, hold on a second. That's not it. Otherwise, I wouldn't have this chart over on this side. Just as a quick reminder, I can have an initial side here, right? And I can go in the opposite direction. So clearly, I could have negative 90 degrees. That could also be a quadrantal angle, or negative 180 degrees, as long as my terminal side ended here. Or negative 270 degrees. If it kept going and went all the way to here, it would be negative 270 degrees. And then so on and so forth. Pretty simple. Not bad. Wait, there's more. Oh, man. Oh, I need some more coffee. You guys are going to watch this just to watch how stupid I can act. This also could be, let me take out the eraser. I could also have a quadrantal angle of so I could also have an initial side here and my initial side here, my vertex there, and have a quadrantal angle that is, let's say, that big. Well, that would be 360 plus the next 270 for a grand total of 0. Let's see if I can do some math. 630 degrees. So that would be a quadrantal angle that's larger than 360. That's possible as well. All right, moving on. Coterminal angles. If you're a co-champion, that means there's two of you that won. So coterminal angles are two or more angles. Where's my notes? Two or more angles that share the same, I'm not even looking at you, I'm writing, it's so rude, terminal side. So two or more angles that share a terminal side. So let's draw an angle in. There's my initial side, straight along the positive x-axis. Or as best I can do. Whatever, jerk. Leave me alone. You guys aren't being nice to me this morning. And I'll draw that ray in. Okay, so here's my angle. I would like a coterminal angle. If I want a coterminal angle, I need another angle that measures that same size. First, we're going to pick the negative. That's pretty easy. I'll just start here, and instead of going in the positive direction, I'll just go in this direction. Let's say my original angle had a measurement of 130 degrees, just to make my mathematics easier, because it is in the morning. Then, if I was going in the opposite direction, that would be 90 plus another 90, that'd be 180, and then plus, let's say, 50 more, I think. Well, how do I get that angle? Well, first of all, I know it's negative, but how do I get it? So we're going to talk about the math for finding these, and they're pretty simple. Shouldn't this angle here and whatever this angle here add up to 360? Sure. But then you got to think, okay, that's pretty easy here. You just go, okay, it's got to be like, what, 230? Boom, done. But what if that was 131.86, or what was that, 132.8749? Then you're like, oh, it'll be, I don't know. So the math is pretty simple. What we'll do is we'll take 130 degrees, and we'll just subtract off 360 degrees. And when you do that, you get negative 230 degrees. So my first coterminal angle, which would be negative 230 degrees. But I said first, right? And in here I even said two or more. So there could be an infinite number. Let's find the first positive. Well, the first positive would start here, and we can't stop there, that's the same angle, and we just come around one more time. Well, what was that one time around was 360, and then we went the additional 130. Well, the math behind that one, then would just be 130 plus 360 degrees. Kind of makes sense? You're just adding an extra circle in, or subtracting off a circle to get to get back away around the other way. And this math hopefully then would be 490 degrees. And of course, if I wanted to, I could go twice around. If I went twice around, I would go 130 plus 360 plus 360 if I needed another positive angle, and then that would be 720 plus 150, which would be something like 850. All right. So I'm going to give you an angle, and after I give you this angle, what you should probably do is pause this video. Nah, you know what? Let's just go through it. Let's put that angle right... No, that's not going to work. Let's not do that. Let's do it this way. Let's do it this way. Draw, we'll go back to blue, and we'll put that angle measure right there. No. Why am I doing that? That doesn't even make any sense. I have my notes here. Let's go with the notes. What do the notes say? I know. Go back to drawing. Notes say put the angle right there. But just to make things a little bit more difficult for you, we're really not talking about that little angle. We're talking about that reflexive angle. Remember, a reflexive angle is an angle bigger than 90 degrees. So, what do you say we call that negative 300, just to make things a little bit simpler. Okay, well, the math is pretty simple. We're going to take the negative 300, and the first thing we're going to do to find the positive angle is add 360. Okay, not a problem. That's 60 degrees. So, in red, I will say this angle right here is 60 degrees. And then to find the negative angle, what I'll do is take negative 300 and subtract off 360 degrees. And we get negative 660 degrees. Which would be if let me grab like black. If I started here and went one time around, and then all the way back to there for a negative 660 degree angle. Perfect. All right, so I'm going to put the angle measure up. You hit pause, try to draw it, and then hit play. See if you got it. Then I'll put the angle measure up. You hit pause, see if you get it. I'm just going to keep going, but your job is to hit pause. I'll tell you, I'll say hit pause now. I'll take a drink of my coffee while you're pausing, and then, no, I won't. All right, so my first one here I want you to do is, let me go back to red. It makes it so much easier. 50 degrees. I would like you just to draw a 50-degree angle. Hit pause now. You're pausing. I know you can't hear me because you're paused. You can't hear what I'm saying, and I'm drinking my coffee because you've got this pause. Oh, are you back from the pause? Oh, jeez, you didn't catch me drinking, did you? All right. All right, don't forget you must draw in the initial side and you must draw in the terminal side. And there is your angle. Theta. Woo-hoo. All right, next angle. How about we do 195 degrees. Hit pause now. Okay, you unpaused? Good. Initial side here. Now wait. Let's think. If I go here, that's 90, and I go another little 90, that's 180. Because remember, those are those angles you got to memorize. And 195 is just a little bit more. It's 15 more degrees, so we'll go a little bit past that. I'm not asking you to be protractor accurate. I'm just asking you to be close. Okay. Perfect. Nice job. Let's try a couple negatives. How about negative 120? Negative, no, that's too easy. How about negative 165 degrees? Hit pause. Good pause face, huh? I like that. That was nice. All right, now you're rewinding it to see if you can pause it at that cool pause face. And you're like, okay, now I'll take a picture of it. Now I'm going to use it as, I'll post it up on Snapchat so all my friends can say how crazy my math teacher is. Wait, why are you guys doing that to me? That's just mean. All right, here we go. 165 degrees. Let's go. 90. Keep going. 180. Oh, shoot. We went past it. Doggone. Oh, that's just terrible. We'll erase that. No big deal. Oh, gone. And we'll try it again. Oops. Yeah, that's fine. So, 90. And then not quite 180. We'll end a little bit early. There it is, right there, negative 165 degrees. Okay, last one. Let's try negative 340 degrees. Seriously, Cross? Are you serious? We're going to have to do negative. I can do this. Did you pause it? Do I need to give you another pause face? All right, there's my pause face. Hopefully you had enough time to pause it. Now you're going back and forth trying to get that pause. Can you get that half a second in there pause so you can get that face? I don't think you can. I don't think you can do it. It's a challenge for you. All right. So 90, 180, 270. Now all the way around would be 360. We're not quite getting there, so I'm going to be about 20 degrees short. Put that in there right there and go right there. Negative 340 degrees. Kabam! Okay. If you'd like, at this time, I would like you to pause this video. We've talked about angles that are coterminal, and I want you to find one positive and one negative angle that are coterminal with the angle I give you. So go through, take a couple seconds, pause it. I'm not giving you a pause face, so don't even look for it. And see if you can find an angle that's coterminal with one of these two. Pause it now. Now that you're back. That was kind of cool. You went on a little break. And now you're back. So, here's the math. Negative 45 degrees. Plus 360 is equal to 405 degrees. No! What am I doing? Going the wrong way. You'll see it in a second what the heck I'm talking about. I don't even know what I'm talking about. Let's go back. This would be 315 degrees. Then we'll take negative 45. And we'll subtract off 360 degrees. And we will get negative 405 degrees. Alright, that's done. Negative 280. Going to add on 360 degrees. Remember, these are degrees. And you really want to use that degree symbol because in a few minutes we're going to talk about this thing called radians. Just to make life a little bit more difficult for you. We don't like you kids. We just like messing with your brains. Can we go back to little math that was so easy? No. What is this? 80 degrees. What do you all agree? 80 degrees? Did I do my math correct? I hate to think I didn't do my math correct. All right. Negative 280 minus 360 degrees. Degrees. Well, that's like almost 300. So this would be like almost negative 660. But it's a little bit less. So that would be what, like negative 640? I'm guessing that's about negative 640. Check my notes. Oh, God, good. All right, over here we'll take the positive angle first, 250 degrees. We'll add 360 degrees, and we will get, let's see, 500, 610 degrees. And then we're going to take 250 degrees, and we will subtract off 300. I wasn't even looking at you for a long time. You guys are feeling neglected. I was looking down all the time. You were, feeling like lonely and upset. I'm sorry. Negative 110. All right, if I screw up the math, it's kind of embarrassing. This one's easy. 100 degrees plus 360 degrees. Oh, I can do that, Mr. Krause. That's easy. That's like 460. And then take 100 degrees and subtract off 360 degrees, and we get negative 260 degrees. Sweet. Done. Degrees, minutes, seconds. Now, you probably don't have the Texas Instrument Inspire calculator that I'm going to be using for this. You can download that if you go to my website, mrkrausmath.com, and you, right on the homepage there's a link on how to get this. Now, you can get it for a 30-day trial period for free, but I would suggest that you either download this and have it on your computer. You can, for a year, it costs $29, or you can buy the calculator. It's kind of expensive. It's like a $100 calculator, $130 calculator, but it will become important. And let me talk to you about just a little bit about why you would like to do this, and I'll show you how this is done. But let's say a totally unrelated topic, but let's say I was driving in my car. Driving in my car. Listen to Pandora. Oh yeah, going in the road, going on a road trip, and it takes me. Okay, let me just remind you. It's now 6:10 in the morning. No more coffee. I think I was beginning to slow down there a little bit, so now I'm a little bit better. So, x equals. Let's say x equals 4.65 hours. I'd like to memorialize what one of my students said. SE, and you know who you are. Yeah, they said, what do you think this means? They said this is 4.6511 hours. And one of my nice young ladies, okay, sort of, said to me, that would be 4 hours and 65 minutes, Mr. Krause. And then I think she immediately goes, what the heck am I saying? Oh my God, did I say that out loud? I can't believe I said that out loud. That's okay. It's fun to make mistakes and have everybody laugh at you and wonder what the heck is wrong with you. Okay, never mind. So clearly this is 4 hours. And then I think when we all stopped laughing, we realized, oh yeah, this is a little bit past halfway. 5, 10, 10 minutes, I don't know, something like that, past halfway. But how do you check? Well, you take out your calculator and you go to your calculator mode. This is what you would get if you downloaded that software. This is what you would get onto your computer. Just want to see, I don't remember the number exactly. There it is. So I'm going to take this. Okay, shrink this. Okay, I can shrink it pretty good. Okay. And I'm going to go into calculator mode. And let's see. I want to do. I don't know why I'm seeing all this. Okay, whatever. Well, I don't care about the 4. What I really care about is this 0.6511 of an hour. But I want to convert to minutes, so I'm going to multiply, because this is 0.6511 hours. I'm going to multiply by 60 to figure out how many minutes that is. So that's 39 minutes. So I'll come back over here and I'll go, okay, 39 minutes. Now notice I'm not going to deal with the decimals. It's just 39 minutes. Well, I'm going to go back to my calculator, and then the minutes part was the 39. This part over here is how many seconds this is. So I'll go back to my calculator. I'll go 0.066 minutes, and to convert to decimal or seconds, I'll just multiply by 60, and I get 3.96. I don't know, not what I got in class, but it's close enough. 3.96 seconds. So 4 hours and 65 minutes. I almost said it myself. Converts to 4 hours, 39 minutes, and 39 seconds, or 3.96 seconds. Well, the good news is you're probably excited to hear this. Although we do have to do this in mathematics, your calculator will do it for you. So let's say I had an answer where theta turned out to be equal to 32.7419. And I would like to convert that to degrees, minutes, and seconds. First of all, let me tell you, degrees has a symbol you already know. It's the little circle. Minutes has one tick mark or one single quotation mark. And seconds has 2 tick marks or double quotation marks. So when you see this come out, it'll look like this. It'll have the degrees, it'll have the minutes, and it'll have the seconds. Only the seconds will have a decimal on it. Every other one will be not rounded, but truncated. Okay? Just like I just did on that last problem. But the calculator is going to do it for us. So in this one, we will take out the calculator, and we're going to first type in 32.7419, and we have to DMS it. I'm not sure your teacher will call it that, but we're going to DMS it. So the easiest way to DMS it is to click right here. It's above the division symbol. If you can't see it, it's right here above the division symbol. And we're going to click on that, and it brings up the catalog. Now, mine's already there, so let me just show you this is what it would look like if you hadn't used your calculator before. You might have a bunch of tabs. It might not even be on the right tab when you get in there, you know. So you have to click on the catalog tab. Now, I don't want to scroll down. It'd take me about an hour to get down there. I mean, I could hold it down and just go. But I'd be there forever. And I'm still in the A's. So to get to the D's real quickly, I come down here and I click on D. And I'm at the beginning of the D. So I'll just scroll down until I find the one that says DMS. All right, so now anytime you have an arrow before you, basically what that says is take the previous calculation or the calculation the person has typed in and do this to it, whatever this is. In this case, we're going to DMS it, degrees, minutes, and seconds. We're going to convert it to DMS. So now in your calculator, you see this, the arrow, and you're going to DMS it, and when you press enter, you get 32 degrees, 44 minutes. Let me write that down. So theta is equal to 32 degrees, 44 minutes, 30.84 seconds. And you're going to be responsible for putting that single tick mark and that double tick mark. Now, here's the thing that's really aggravating, because you're probably like, well, that's easy. I hope they have a lot of questions like that on the Radians exam. They do. They do. But they're going to kill you with the rounding. They could say, round this to nearest second. I'm going to round this to nearest, put that in there something, second. Okay, round to the nearest second. Did I erase all this? What happened to my notes over here? My whole note. Oh, did I erase it? I think I erased it. Give me a second. It's there. Oh, yeah, that's right. I erased it. I can't believe I forgot that I erased it. Oh, my God. I can't believe I erased it. Well, okay. To the nearest second, then it will be 32 degrees. Gotta love coffee. 44 minutes, 31 seconds. Or I could tell you to round it to the nearest 10 seconds. Oh, okay. That would be 32 degrees, 44 minutes, and 30 seconds, because rounded to the nearest 10 would be 30 seconds. Or I could tell you to round it to the nearest minute. That would be 32 degrees, 44 minutes. Or I could tell you to round it to the nearest 10 minutes. That would be 32 degrees. In this case, 44 rounds down to 40 minutes. You gotta go actually back up here, but whatever. Or I could tell you to round to the nearest degree. Wow. So you really have to be a reader. You have to pay attention. You got to read what it says. Take that highlighter with you to your test. Underline that stuff and the important stuff, because you got to remember that probably somewhere around 5 to 8 percentage points on this Regents exam, at least in the past, maybe it's not true as much as anymore, but in the past, and it will, who knows if it's going to be on the next one, is about rounding. Making a dumb mistake with rounding. You can miss 3-4 points with rounding. It's crazy. Don't do it. All right, so let's try another one. Let me erase some of this. Let me erase this. And whoosh. Oh, that's hard to erase. Let's try another example. What if I said, let's do theta is equal to 281 degree. Oh, no. Point. Dang. Get rid of that. 0.7856. I don't know what this is going to turn out to be. I've never done it before. Let's see it. So, 281.7856. And then we're going to DMS it. Now if I go to catalog, since I've already DMS is already highlighted, I just press enter. I DMS'd it, press enter again, and I get 281 degrees, 47 minutes. 281 degrees, I already forgot what it said, 47 minutes, 8.16 seconds. 8.16 seconds. Now, I didn't even say it. They couldn't say round to the nearest tenth of a second. It'd be like 8.82, 8.2. Really? This one would round, if I rounded it to tens, would be 10 here. With this rounded to tens minutes, that would be 50 minutes here. Could ask you all kinds of things. Then they could say, okay, let's say theta is equal to 117 degrees, 23 minutes, and 14 seconds. What is that as a decimal? Okay. I know it's going to be 117 point something. I know also that point something is going to be less than a half. This is 23, so it's probably going to be like 0.4, 0.43. I don't know. Let's see. What you're going to do here now, this is kind of creative. This is done a little bit differently. Okay, I keep hitting the wrong thing. Okay, I don't know. All right, I'm just going to have to snap back and forth. So, 117.23. So I'm going to do, so here's how this works. What you want to do is you want to go to this button right here. It's next to the catalog, and it's this crazy, all this stuff you're looking at going, I hope I never have to learn any of this. Well, you already know fraction. You already know absolute value. Here's degrees, minutes, seconds right here. It doesn't say it, but you got to look at it. See the degree symbol, the minute symbol, and the second symbol? It's right there. So click on that. Hit enter. And there it is, degrees, minutes, and seconds. I already forgot what I put in. So 117, so 117, 23, 14. So 117 degrees, 23 minutes, 14 seconds. And their answer would be... Okay, so go up there. Oh, that's right. You have to hit the up arrow. Hit enter. Retypes the line. And when it comes out into remembering a decimal, you just put a decimal in the problem. It'll turn it to degrees. There it is. 117.387. 0.387, and it looks like a whole bunch of twos. And so if they can tell you to round to the tens place, the hundreds place, whatever. Okay, that's DMS. It's not very complicated. The hard part is remembering it to round. Radians. So after trig, predominantly when you get to upper level math, you will stop using degrees and you will start using radians. Radians are measures that are ratios of actually how large the circle is. They're well, let me describe ratios to you, and I'll give it to you as much as you need to know. I'm certain your teacher will never ask you to regurgitate all of this information, but I think it's something good to know. Let's say we're given a circle. That's a perfectly round circle, and the circle has a center. We'll draw this thing in here called a radius, so we'll put an R there for radius. And let's say I take a piece of string out and I measure that thing, and I take my string out and I go, okay, it's that long. And then I come over here, I shouldn't have picked that color, and I draw it and I put it right along this, so that this distance is also R. By the way, this is called an arc. And we're going to use the letter S to represent arcs. But for now, I'm just going to put an R there. But we use the letter S for arc length. You're thinking to yourself, we got some crazy math teachers, man. S. Why don't you just use A? Think about it for a second while I take some coffee. That's right. Because A used for almost always and predominantly area. All right, so let me draw in the, so we'll use S, other radius. So here we have theta. Now, theta is an angle who has a radius R, and it intercepts an arc that's got the length R as well. So R is the radius as well as the arc length. Okay. So that is said that therefore theta is equal to 1 radian. Ta-da! That's where radians come from. Now, this radius, when laid out once, twice, and over to here, which would be 180 degrees, and later on we're going to find out that 180 degrees, I'll write it down here for you, is the same as pi. So this is the degrees, this is the radians. They're equal or equivalent. What do you call the distance all the way around a circle? While I'm erasing that, think, use your brain. What's it called? That's right, it's called the circumference. And the circumference is equal to 2 pi r. Now, if I divide by r, I get 2 pi is equal to the circumference divided by the radius. Now, what I should have come back over here, and I should have said that theta, I forgot to do this, theta is equal to the radius, which I told you, or I'm sorry, the arc measure, which I told you we're going to call S. So let me erase that. I told you we're going to call that S, is equal to S divided by R. It's that ratio of the arc divided by the radius, which, since they're the same exact thing, theta equals 1. Now this thing right here is going to convert to a formula we're going to use later, and I'll talk about that in a second. But isn't this here, when I go back to talk about a circle, isn't their circumference the entire distance around a circle? And aren't we dividing by the radius? So this should be equal to our angle. Well, all the way around a circle is 360 degrees. But what you're finding out all the way around the circle is also 2 pi. So what do I want you to remember from this? First of all, I want you to remember that radians is just a different degrees, different way of measuring angles. It is the ratio of the arc length divided by the radius. And that's why it's kind of a more useful way of measuring when you get a little bit upper level mathematics. I want you to remember that it takes 1, 2, 3, and a little bit, we'll call it 0.14159, or there are pi radians. Let me say that a little different way. There are 3.14159 radians in half of a circle. Well, didn't we say half of a circle was 180 degrees? So therefore, it goes back to my point that 180 degrees is the same as pi radians. Well, if half the circle is pi, then all the way around the circle would be 2 pi. So 2 pi radians would be the entire circle, and that's equal to 360 degrees. So that's where radians come from. You're going to have to be able to convert back and forth between degrees and radians. So this is that year that you're going to have to do that math. You're going to have to convert, and this is where we're going to convert. Now, the only way I can convert one thing to another, for example, when you took 3/5 and you wanted to add it to 7 7/15, you had to convert this to something that I could add to this. And you did that by multiplying by 1. But you did that by multiplying by 3 over 3. Because that would give you 9/15. And you say, okay, now I can add that to 7/15 and get 16/15. But you had to multiply by 1. Well, that's all that we're going to do here. We're just going to keep multiplying by 1 in order to convert from degrees to radians. So, let's say I have degrees, and I want to convert over here to radians. So I have theta degrees. I probably should have written theta radians over here. But I have theta degrees. You're going to multiply by 1. Well, didn't I tell you a couple of minutes ago that 180 degrees and pi were equivalent? Therefore, I'm really just multiplying by a really fancy 1. Pi over 180. If I want to convert back, I'm going to multiply it by the reciprocal, but it is still 1. These are still the same terms, same quantities. Pi, 180 and pi are the same thing, so I can multiply by that. Here's how I like to remember it. If you're in degrees, you don't have a pi. You need a pi, so pi's got to go in the numerator. You're multiplying it. When we get rid of things is when we divide by them. And so if I'm in radians and I want to get rid of pi and I want to convert it back to degrees, I got to get rid of pi. The only way to get rid of pi is to divide by pi. That's how I try to remember it. So I'm over here and I'm going to convert from 60 degrees to radians. Well, I want radians, so I need a pi, so I'm going to put pi in the numerator, and I'm going to multiply by pi over 180. Well, this is clearly 60 pi over 180. But you'll never ever want to leave it like this because you need it in its simplest form, because when we do future stuff with sine and cosine, tangent, cosecant, cosanding, all that crazy stuff, you're going to want it in its simplest form. So what we'll say is, okay, we cast out the zeros, get rid of the zeros, and 6 over 18 is 1/3. So this is pi over 3 radians. And we'll do this a couple times. We'll multiply by pi over 180 here, and we get 150 pi over 180. Get rid of the zeros. 3 goes into 15 5 times. It goes into 18 6 times. So this is 5 pi over 180. All of these are going to become very important. You can do the same thing with negatives. Negatives doesn't matter. Your answer is just going to be negative. Pi over 180. So this is negative 45 pi over 180. Not quite as easy, but if you double 45, you get 90, and you double 90, you get 180. So it really just goes in there 4 times. So this ends up being negative pi over 180. Now the cool thing is, let me bring up the calculator real quick. Let's say you didn't know that, and you typed in negative 45 divided by 180. It will tell you it's 1/4, or negative 1/4 in this case. So not bad. Oh, I just wrote down the wrong answer. Negative pi over 4, not 180. 90 is really easy. Pi over 180, multiplying. Why am I saying equals? We're multiplying by 180, and we get 90 pi over 180 degrees, or pi over 2. And you're going to have to do this over and over and over again. Sometimes they ask for these in decimal form, which just means you're going to have to put this in your calculator. Pi over 3, you just take pi, divide by 3, blah, blah, blah. Not a big deal. Now we're going to convert backwards. Well, if we have pi and I want to turn it to degrees, all I'm going to do is multiply by the reciprocal. I want pi down here now in order to get rid of it. And I'll put the 180 up on top. So in this case, the pi's will go, and I end up with 180 divided by 6. Well, I know that's going to be 30 degrees. If I take this one and I multiply by 180 over pi, again, let me go back. The pi's are going to cancel. 2 goes into 180 90 times. So I end up with a 3 and a 90, or 270 degrees. That's one of those ones you're going to become really familiar with. And this, negative, no big deal. Oh, why do I keep putting equals? Maybe I need some coffee. I know that's what you're thinking. Wow, I've become so boring. I got to get some coffee. Oh yeah, nothing much better than a hot cup of coffee. Now I've been down here for almost an hour now, so my coffee's getting cold. I'm gonna have to go up and get some new ones. Cancel those pies. Now, again, let's figure out what you're really gonna do. You're gonna take out your calculator. You're gonna do, okay. We're gonna go to fraction mode, and we'll do We'll do negative 3 over 4 times 180. Pop that in, it'll be negative 135. You're like, oh, okay, I got it. So it's negative 135 degrees. Now, this is interesting. There's no pi to get rid of, but that's 3 radians. It's not 3 degrees, it's 3 radians. So we're still going to multiply by 180 over pi. But notice, there's no pi to get rid of. So I'm going to absolutely have to go into my calculator and type in 3 times, and we'll go into fraction, 180 divided by, I think it's down here, pi. And there's your conversion, and you say, oh, that's 171.887 degrees. 170, I already forgot. 1.8, let's just go 0.887 degrees. Didn't tell us we're around. Okay. Pretty simple. If you want pi, if you have degrees, you want pi, you leave pi in the numerator. If you have radians, you want to get rid of pi, or you have radians, you want to get rid of pi. Pi goes in the denominator. But it's always going to be multiplying by 180 over pi or pi over 180. Let me go back up here to this formula right here. I'm going to, let me do it in yellow, mellow yellow. We're going to use that formula right there. That theta is equal to, when we're working with radians, now this only works with radians, the arc length, S, divided by the radius, R. We're going to use that over here to find arc lengths. So, the formula I had over there was theta is equal to the arc length S divided by the radius R. Remember, S stands for arc length. Now, what does that mean by arc length? I probably should have drawn a circle here. Let me draw a circle. Well, let's just say this. Let's say you want to know how much your dog is walking, and you're one of those great parents that, by the way, this is never a good idea to put your dog on a leash in the backyard. Just torments a dog. But if you have to, you have to. But you put the dog on a leash, and let's say the leash is 10 meters long. And you know you've now completely made your dog a psycho, and all your dog does is walk here and walk back, and walk here and walk back, and walk here and walk back. And you want to say, hey, I wonder how much my dog's traveled today, because everybody wants to know how much their dog's traveled. I don't know. How much distance is that? What's that? How much distance? I just said how much distance is that? Well, the first thing you got to know is what is that angle that he's allowed to travel? And if you know that angle, how much he's allowed to travel, and you know how long the rope is, why did I write 10 minutes? How about 10 meters? I know, y'all think, I know, more coffee. Ooh, running low. We're almost done. This should be done in just a couple minutes. This stuff is so simple. I'm going to use this formula over here. It's a very, very simple formula, but I'm going to convert it because I want to convert it so that I want to know what S is equal to. Well, again, think about it. If I cross multiply, I get S equals theta times R. Now, here is the one thing, I'll draw that better. Here's the one thing that you must, okay, I guess I'll start all over. You must pay attention to. This formula only works when theta is in radians. It does not work when it's in degrees. And that's because degrees don't take into consideration the size of the circle. It is a ratio. Radians are like using the size of the circle as a ratio of how big that circle is. So you're not able to do this using degrees. You must use radians. Okay, well, we're just going to use this formula. And that's it. It's actually quite the simple formula. It's probably one of the easiest ones you'll be given. You must memorize this formula. I don't know how much I can drive home the point. Start making flashcards. You must memorize that formula. That will not be given to you. Now, it's an easy, you're like, oh, this is the world. This S equals theta R. It's easy. Yeah, I know. Don't memorize it. You'll remember it. Sure you will. You won't have to. We'll end up doing some flashcards, but if you want to be proactive and start doing some flashcards early, let's start now. All right, so let me go back to my green. We have, if the arc length of a circle is 12 inches and the radius is 4 inches, find theta. Okay, that's a clear, right there, boom, that S equals theta R. That's an S equals theta R. SOR. S-O-R. SOR. S theta R. So, what do you know? Well, you know that the arc length is 12. You do not know theta. And you know that the circle is got a radius of 4. Okay, so theta is equal to 3, because you divide it by 4. I'm assuming that you all see that I divide by 4 here. Radians. I told you it was easy. It's easy in when I do it. It's easy when I just have you do simple little things. It gets much more difficult later on. And stay with me because I think one of these problems is kind of tricky, or not much trickier, but a little bit trickier. All right, let's see. We got arc length is 12 and theta is 6. I want to find the radius. All right, S equals theta r. I know my arc length is 12. I know my theta is 6 radians. What is my radius? All right, we'll divide by 6. Divide by 6. And I get r equals 2. 2 what? Must be 2 inches. Moving on. Find the arc length. Oh, arc length. S equals theta r. All right, let's see. We don't know the arc length. S. We do know that theta is 2.5. I should have put radians in there. I apologize. I should have said 2.5 radians. Times the radius, which is 8. It's not 8. Careful. I gave you the diameter. Don't be a monkey. Just got to put numbers in. You got to punch some numbers in there. No. Don't make me mad. 4 is the radius. And everybody knows 2.5 times 4 is 10. So 10, and we'd have no units, so I guess 10 is the answer. Oh my God, Mr. Krause, what is that? A pendulum swings at through an angle of pi over 3 radians each and every second. If the pendulum is 40 inches long, how far does the tip of the thingy move? So you guys know what a pendulum is, right? It's like this. Now, assuming there is no gravitational pull and no friction loss, and it just keeps going and going and going, we want to figure out what this arc length is. All right, so SOR, S equals theta r. We're looking for the tip. Well, the tip's down here. We want to figure out how much that tip is moving back and forth, how much it moves. So how far does it come over here? How far does it go over there? So we're looking for the arc length. We were given, thankfully, our answer in radians. So we'll go, all right, pi over 3. And our radius, oh, the pendulum is 40 inches long. So that is the radius, 40 inches. Now, you can't leave it like this, kiddies. S equals, I got to go over to my calculator and go pi over 3. Pi over 3, ka-ching, times, was it 40? I think it was 40, right? 40 equals 41.8879. 41.8879. Doesn't say word around, so I'm going to give it all to him. 0204. 0204. Good enough. All right, last one. This is the tricky one. I would like to know how long my crust is on my pizza. Everybody wants to know that. I mean, come on. So I carefully take out my protractor. I measure degrees, 45 degrees. I take out a ruler. I find out my pizza is 7.5 inches long. There's the radius is 7.5 inches. I cut out a 45 degree angle, and I want to know how long my crust is on my pizza. Clearly, a real life example that everybody's doing. You ask when you want to use this in real life. This is when you want to use it in real life. I'm not kidding. Seriously, this is the last problem. Thank goodness, because it's like 6:45. I'm really getting tired and a little crazy, and I'm almost out of coffee, which is a little crazy. All right, S equals theta r. I want to know how long my crust is. My crust is the outside of a circle, and the outside of a circle is an arc. S equals theta r, SOR. So I'll go, just like a monkey, I'll go S equals 45 times 7.5, and I'll get S equals, I'll come over here, and I'll go 45 times 7.5, and I get 337 inches, 0.5, 337.5 inches. What the heck? That's an amazing piece of pizza, 337.5 inches of pizza. Dude, seriously, I would be so huge if I ate just that one slice. So clearly there's a problem here, isn't there? That's why I said it's a tricky problem. Clearly there's a problem here. I'm not having a 7.5 inch pizza doesn't have a 337.5 inch arc. Doesn't make any sense, does it? Well, that goes back to why these problems are a little bit tricky. They're not bad, but they're a little bit tricky, and you have to be careful. This is your problem. Can't use 45 degrees, so this clearly is a stupid answer. I said a little while ago, and I said the one thing you have to make sure is that you remember that your degrees, your theta must not be in degrees. It must be in radians. So you have to convert this. Now I want pi, so I'm going to leave pi in the numerator. I'm missing a pi. Pi is radians. I want pi, so I'm going to put it in the numerator. So I'm going to multiply by this. Now you don't have to reduce this. You know this is 45 pi over 180. Now later on, when using it here, you don't have to reduce it. But later on, you're going to want to always reduce it. In this case, it's pi over 4. But let's say I didn't know that. Let's say I'm just saying, okay, I just know it's 45 pi over 180. Oh, okay. So I'll go to my calculator, and I'll go, give me a fraction. And I'll go, okay, 45 pi over 180. That's that part. And times 7.5 times 7.5. So this over here is the conversion from degrees to radians. This part, this first part, it's now in radians. It's really pi over 4, and that's really 3.14159 divided by 4, which is, you know, a little less than 1, times 7.5. And this will tell us what our arc length is. When we press enter, and we get 5.89 inches. And let me write you down exactly what it is. It's 5.89049 inches. And since it did not say to round, almost every single time you do these problems it will say to round, but in this case it did not say to round. You don't have to round. That's it, kiddies. I hope it was easy. I hope you had fun. I hope you come back and see me sometime. Oh, Mr. Crows, signing off. I think that's it. See ya, bros. See ya, girls. See ya, kitties. Bye.